Late Night Chemistry with Mr. Harden. Today's topic, Lab Safety Tour. On this tour, we will look at all the safety features in this classroom and explain how and why or when they're going to be used. Our first stop is the fume hood. So the fume hood is a place that you'd go to if you were doing something to produce, say, some noxious or hazardous gases or fumes, because in this fume hood, there's these controls that will, you can hear that, that's a fan that will pull fumes from out of this cabinet and suck them right outside. This cabinet also has its own lighting system, which might be hard to see with the outside lights on, and its own water, and its own gas supply. Second thing that we would use this for is if something was, say, doing an experiment. Let me turn that fan off for a second. And we need to have it under more controlled conditions. Well, we can do this under behind a thick pane of glass, which will contain more vigorous experiments. Now, it is not a substitute for wearing other protective measures because there is a little gap between the glass and the wood that you can actually get a part of your finger through, which means things can and have managed to get out of this. So I've done a demonstration before inside this hood where a little spark landed right around there on the floor. So you still would have to wear glasses, but it does offer extra level of protection. The other thing the safety foot has is a spot to store additional spill materials. I'll open this cabinet. There are extra materials to handle chemical spills. We'll talk about those more later. Stop 2 is over here. There's a little black button. It says push to call, and the area is labeled intercom. That would put you into communication with the office. And that would be used if there's an emergency that we needed to contact the office with very quickly. A life-threatening emergency, someone would need to just pull out their phone and dial 911. This is our third stop. This is where we deposit broken glass. So if there's any broken glass that you end up producing in one of these labs, accidentally of course, this is where you dispose of it. Broken glass can't be disposed of in the normal garbage because then it means there's a hazard to whoever picks out the garbage. They could easily injure themselves. So all broken glass would need to be deposited here. And other things that aren't exactly glass, but produce equally sharp things when broken. For example, a broken ceramic dish would have to go in here as well. Now, on top of this broken glass container is a glove. So that will allow you to pick up large pieces of glass and without cutting yourself. For really small pieces of glass, there is a broom and a dustpan that you can use. And there are also some other little tricks that I can tell you when it happens. This is the spill station. Like it's labeled, this is where you would go if you had some sort of chemical spill. I'm going to pull the items out of the spill station and put on the bench right behind me so we can go ahead and talk about them in a minute. So here's some of the stuff in the spill control center. We have sodium carbonate and baking soda, also known as sodium hydrocarbonate, which are both really useful for cleaning up acids. We have something that's labeled Easy Pour Base Neutralizer, which is really good for neutralizing bases. Its content is just citric acid. Um, we have sand, and we also have more sand, and we also have even more sand. Sand is a very useful to contain a spill. So if you had a nasty spill, the idea would be is that you could use some sand and you could make a little barrier around it. The spill would spread out until it ran into the sand. The reason sand is useful is it's a very inert material. There's hardly anything that will react with it, and it could contain the spill so it just won't spread any further. We also have material to absorb a spill. In this container and in this container, a really good material for it is kitty litter, and that's one of the things that was underneath the fume hood was a big 50-pound bag of kitty litter. Now, why do we have so much material? Well, the rule of thumb in the lab is that if you would take the largest bottle of any chemical that I'd have, and if that would completely spill out, we would need enough material to handle that spill. And we definitely have enough material to handle a large container of acids and bases, and for more wicked stuff, maybe the sand or the absorbent material. Now, which one would you use in the spill? Well, the answer is depends on what's spilled, which I know is very vague, but the complete answer requires just know a very large amount of chemistry, which at this point you probably aren't expected to know, but as the instructor, I would know. So if there's a spill, what would be expected of you to do would be to inform me of the spill, and then if it's something I think that you could deal with, I would tell you what to get from the spill center and how to handle the spill. If it was something that was outside of the safety zone for students to work with, well then I would handle cleaning up the spill. And if it was outside my safety zone, then we just need to evacuate the building. That's going to be pretty unlikely. Our next stop is this little cabinet right here in the corner. There are two safety features that we would need to talk about. One of them is the safety shower. So the idea of the safety shower would be if you somehow got chemicals all over yourself, what you would do is you'd come to the safety shower. There is this little metal triangle basically hanging underneath it. You'd pull that down. You don't have to hold it down because once it's down, it'll stay down until it's pushed back up. And then water would come from here like a shower, but not like an ordinary shower where you get a nice amount of water. This is a super high volume shower. The idea is to wash off whatever chemical is on you. If you get something on you, depending on how dangerous with it, you might be underneath that shower for up to 20 minutes. Again, that depends on how dangerous that material is. Let me point out something of interest to you. Here's the floor. Here's the floor in focus. There is no drain for the shower. So if you would use a safety shower, you're going to make a huge mess in this classroom. Which, if you have a chemical all over yourself that's dangerous, you're not concerned at all about making a huge mess in the classroom. You're just concerned about getting the chemical off of you. You would be concerned if you don't have chemicals all over you and you make this huge mess. That's a different story. Now, this is the eye wash station. So you use the eye wash station if somehow you'd get a chemical in your eyes and you would need to get it out. So what you would do is you'd come over to here and you can pull off these little gray, the little kind of things to protect the eye wash station. If you forget to pull them off, then you use the eye wash station, they'll probably bounce off the side of your head. Now what you do is you stick your face right in between those two spots, and there's this lever that says push to operate, and you push to operate, and that's where your face goes, and the water will wash stuff out of your eyes. Oh, it also makes a big mess too. But again, if you actually have to use this, you're not worried about making a big mess. You're just worried about getting stuff out of your eyes. Depending on how dangerous material is, you could be having your face up to 20 minutes in there washing things out. This also is something where brings to mind something from the safety contract, which is about contact lenses. You are allowed to wear contact lenses in the lab, but if you do get something in your eyes, it just makes your life one step more complicated. Contact lenses will trap chemicals between your eye, between the contact and your eyeballs. So if you do get something in your eyes, somewhere in the process of washing stuff out, you have to remove your contact lenses. If you're lucky, the pressure of the water will wash them away. If it doesn't, you'll need to peel off your contact lenses and then continue washing it for however long you need to. Now, you're not very likely to use a safety shower. This is very unlikely to get chemicals all over you. And you shouldn't be getting anything in your eyes because you're wearing safety goggles in our lab. Most likely place to be exposed by chemicals is your hands, because you use those to manipulate everything, and so they'll be the first thing in harm's way. Well, you don't need a safety shower or an eye wash station to deal with chemical exposure on your hands. You could use a sink. I have 6, 7, 8, 9 sinks in this room. I have 2 sinks in each lab bench. I got 3 lab benches. There's a big sink beside the area of the lab benches. The demonstration table where we on the other side of the room also has a sink, and there's a small little sink in the corner of the fume hood. Not very useful, but it's still a sink. So if you do get something on your hands, you would go to the closest sink and wash it off immediately. Here is our collection of safety glasses, or safety goggles, whatever you want to call them. Anytime there's any chance of having a hazardous chemical to get in your eyes, like a liquid or a solid, you would definitely be using these safety glasses. Safety glasses can be worn over glasses, and they can be adjusted to fit your face. Though if you adjust them to fit your face, don't tie knots in them so that it fits, because then it might be perfect for your face, but the next person uses it is not perfect for, and they have to remove the knots, and that is a huge problem. Over in this area, there are 3 separate things that we can talk about. First thing is we have these lab coats. These lab coats are black, so they do go with everything. And they're used to protect you and your clothes from being exposed to hazardous chemicals. They are resistant to most chemicals. They're definitely acid resistant. So if you get anything on you, on there, instead of your clothes, then your clothes are protected. And you, underneath your clothes, will be protected as well. If you got stuff all over the front of this lab apron, you could just take it off, stick it in the sink, wash it off, and it would be as good as new. Once it dried, it would be 100% as good as new. When we're thinking about being exposed to chemicals, you usually are thinking something big, and more likely it's something small. So what sometimes happens is this: say on the surface of these lab bench, some students, not you guys, but some students may not be good about cleaning up after themselves, and they can leave behind a little residue of chemicals. And if you lean up against it, you can transfer some chemicals onto you. Another likely scenario is you're working with some chemicals, say an acid, and as you're manipulating things, a little drop escapes and lands on you. So unlike the movies, it's not going to be dramatic. You won't see smoke, you won't hear hissing, you probably won't notice whatsoever until you get your clothes back from being laundered. And at that point, your clothes are now holy, but not in the way the theology department likes to talk about holy. There's just extra ventilation. So the lab aprons will prevent that from happening to your clothes. They won't protect it perfectly, but they do really help. Next up, there is a fire blanket. So you can see the fire blanket, there's a little material sticking out this little circle. The way you'd use it is you would open up this bottom, grab the fire blanket you can see underneath it, and just pull it out. Now what the fire blanket can be used for is like 3 different things. One, if there's a fire, it could be thrown on top of the fire. The fire blanket is not flammable, and it can be used to then put the fire out by depriving it of oxygen. Second, if you get a really nasty spill and you need to contain it really fast, you could throw the fire blanket on top of a spill, and it could absorb the spill and prevent it from spreading. And sure, it would probably mean we need to replace that fire blanket, but if that was needed to control a nasty spill, that's a small sacrifice. The third use for a fire blanket is it can make a handy makeshift curtain. Now, the reason I bring that up comes back to the safety shower. There's no curtain there. And if you get chemicals all over yourself and you use the safety shower, the odds are you're going to have to lose the clothes because those clothes would all have to be contaminated. So what we would do then is we'd have a couple of students say grab the safety blanket. Would probably make sure if it was a guy in trouble, we'd have a couple of guys grab the safety blanket. If it was a girl, it'd be a couple of girls grab the fire blanket. They could then hold the fire blanket up to make a makeshift curtain. Everyone else would be asked to leave quickly from the classroom. And then for a female student, I would get one of the 2 science teachers next door to handle the situation. If it was a guy, I could then just handle the rest of the situation. I do have extra clothes in the storage room, which is really, really handy if you are my size. If you're not my size, it's less handy. But there's also some extra clothes in the office that we can always send away for that we could use in case of emergency. Final thing in that same little zone is the fire extinguisher. Now, to use a fire extinguisher is really best the people who are actually trained in using a fire extinguisher. Now, I've been trained using fire extinguisher, and someone else might also have some training. But if in doubt, and there's a fire, we need a fire extinguisher, you would bring it to me, and I would use it. The reason training is important is because if you use a fire extinguisher wrong, you could actually make things worse. So imagine that you had like a fire over on this lab bench. I'm using these flasks to represent the fire. So the human nature is when you use the fire extinguisher, you see this fire, you would take it off, you pull the little pin and you'd point it right at the fire and let loose a big blast of of CO2, carbon dioxide, which is what's in most fire extinguishers. The problem is the force of the blast could scatter your fire. Now you've got 3 fires. So you've just made things worse. So what instead is supposed to happen is this. Instead of going right at the fire, you go at the base of the flames instead. And you would just run the blast from the fire extinguisher along the base of the flames, then move a little further in and kind of run past it again. And the idea is just to deprive the fire of oxygen, and then it will go out. But if you go directly at the fire and you blast it, you can make things worse. So that's the reason training makes things, we need training to be able to do that really safely. Now, the reason that we talk about all these safety rules, and the reason we're very, very particular about enforcing the rules, is that I want people to be safe in the back of the room. So they can actually do real experiments using real chemicals and get a real feel for what happens in chemistry. And as long as we are following our safety guidelines from our safety contract, from what you saw in the other safety video and this safety video, and from the demonstrations, we'll be fine. Will I guarantee that no one will ever get hurt? No. People have been hurt in this lab. We've had cuts that have been treated by, say, like Band-Aids. Slight little burns because people thought something was cool and something definitely wasn't cool, and actually burned themselves because of that. We just ran it under some cold water. But nothing really more serious has happened. And as long as we follow the rules, nothing serious should happen. We do have all the safety equipment that we need to handle really, really adverse situations. Okay, we're not back to talk about the fire blanket. Instead, we're going to be talking about first aid kits, which we do have a first aid kit. And we also have extra box of Band-Aids because that's the most common thing used from the first aid kit. In case there's an injury, you would report it to me. And if it's something to be treated from the first aid kit, we'd take something from the first aid kit to treat it. If it was beyond my ability to treat, I would summon extra help to handle the situation. A final note. There are really 2 types of accidents in a lab. There are the type where every single second counts. That is, if you're exposed to a chemical or you get burned, say by touching a hot object or your hand made contact with open flame. In these cases, the faster you react, the faster you do something about it, the less damage will occur. Chemicals will take time to react, and the less time you give them to react, the less damage they'll do. Heat's the same way. So you can treat being exposed to intense heat as a chemical exposure. So the faster you react, the faster you remove that heat, the less damage can be done. Now for heat, you would run it under cold water for a period of time to pull off all the excess heat. It's the way that you would minimize a burn. And for chemicals, you minimize damage done by a chemical by washing it off immediately. So for that type of, hazards, if these accidents happen, you'd be expected to deal with it on your own. As in, if you stop to ask permission to tell me about it, you're giving it time to damage you. So if you get anything on yourself or you burn yourself, you need to immediately respond to it by either washing your hands in the sink or go to the eye wash station or the safety shower, whatever is appropriate. The second type of accident is every other accident. And these accidents, there is time for you to stop and consult with the instructor, me. So if you spill something, you can come consult with me and I'll tell you how to handle the spill. If there's a fire, you can tell me there's a fire and I can tell you how to handle the fire, because different fires would require different ways of dealing with it. And it's up to me to come up with the most appropriate way of doing it, dealing with the problem. If you cut yourself, well, you definitely have time to tell me about it before we go to the first aid kit or call for extra help. So the immediate ones where you have to act on your own are going to be the ones involving chemical exposure or being exposed to heat. And the other accident or mistake, your best bet is to first run it past me and I'll tell you how to handle it. Now, sometimes if in the middle of an accident, you may not be in shape to handle things yourself. Like, for example, if you get chemicals in your eyes, it might be really difficult to find your way to the eye wash station. So it's going to be the responsibility of anyone around that person, whether their partner or not, if someone needs help to use any of the safety equipment, your responsibility to help them use that safety equipment. Anything, questions that you have, there'll be an opportunity during class time to ask any questions.